Okay, we can start here. So we are presenting a different viewpoint. It's a very simple approach for cross-modal classification in medical domain, and we have experimented with this approach in other domains also for cross-modal retrieval. But paper is under submission, so we are not going to reveal the paper right now. But we have shown results. Okay, so going further. So the problem setting is like that we have multiple tables. These tables are related to different diagnostics, and they are basically longitudinal in nature. They are trying to solve the find the same classification. Classification can be some risk associated with the disease, and but these tables are coming from different sensors or different modalities from in the medical domain. And the main problem that the researchers feel is that how do you extract features from these tables and combine them at different stages? The literature is has divided this classification into early stage concatenation, mixed representation concatenation, intermediate concatenation, late stage, and hierarchical. So we have focused upon intermediate and hierarchical concatenation in the down for the downstream tasks. So the classification task that has been given to us is has this multi-label dataset which is independent in for now, and tables T1 to T3 for each patient, and inside the table the data can be correlated. Going further, so our first approach is simple, that we would like to use LSTM to extract feature projection for each of the table for each of the patient I. And so this projections that we are taking using LSTM. So we are going to explain our second approach, which is very simple, and we are using a k nearest neighbor search in our approach. For now, we are just extracting individual projections or individual features for each of the tables. And also we could have done this for in a more hierarchical fashion, that we could have taken out projection for each of the columns, and these projection can be taken out using a BERT like model. Earlier we were in the intermediate form, we were talking about LSTMs. We wanted to extract features for each of the table, and we want to somehow combine them. That is the initial issues that we have. How do you combine these features together? These features can be hierarchical in the sense that they can be for each of the column, or they can be table wise, where we are talking about intermediate setting. Now we're talking about hierarchical setting. Okay, so yeah, so our cross-modal retrieval approach, we have tried this on text and image datasets, and there we have performed quite well, and paper is under review. So what we want to do is that we want to take these hierarchical features or intermediate level features. Either we take it from a transformer or a LSTM, and we want to project them in a lower dimensional space. And while projecting them in a lower dimensional space, we want to do a common subspace representation learning using a pivot. So what happens for each of the table, for each of the representation that you get? Suppose you get representation for images, text, and sound, and you want to create a subspace of with the true and the false label for each of the risk. So you would have the subspace whole space divided into three subspaces. One will be for the risk 1, another one will be for risk 2, and another one will be the risk 3. So finally, what does happen here? So these three independent subspaces, we can use a k-nearest search. Whenever a new test representation come, we can search inside this k-nearest neighbors space, and we can simply output a label for that. We have kept all the labels independent, and we are learning three subspaces right now corresponding to risk 1, risk 2, and risk 3. And these subspaces, whenever a test item will come, we will use a k-nearest search for these representation. So we have so kind of remove that entire problem of feature concatenation. We are not concatenating them anyhow. We are taking independent features of images, for example, images and text, or table 1, table 2, table 3, and we are bringing them together closer using a representation learning called pivot learning. And this is the example we have shown. And this is the whole architecture that we want to use. So a pivot is pivot is dependent on the class label, and class label can be learned in a more deep fashion using autoencoder and for using independent pivots. So there can be two basically clusters. One is true cluster and false cluster for each of the risk 1, risk 2, and risk 3. And at the test time, what we would like to do is we would like to put a query table, and finally we want to search through the original training data, and we can simply tell which of the top k nearest search objects are present in the training data, and we can assign the class label according to that. So this is the KNN classifier approach, and we learn this common representation space through pivot learning. That is the whole approach we are trying. And in our papers, which is under review at a conference, there we have submitted state-of-the-art results for this, and we believe that this particularly will work for the tabular data also. And in comparison to other tabular data approaches like light GBM or XGBoost, which does not work well, given that different modalities will be there and we want to combine them together, we would have to think about a prior, how do we combine these? So here we are removing that problem altogether. We are giving a new perspective to that. That's our approach. Yeah, questions. So we are also thinking about intermediate and hierarchical representation. So either of them can work as per the experimentation here.